Okay, lecture 8, we'll talk about formulation of dispersed systems and freeze-dried powders. So in the lecture 7, we talked about formulation basics, right? Your API, solvent, and other excipient components that are going into the formulation. Today we'll talk about kind of extreme case of formulation where your API may not be water soluble or it may be strongly hydrophobic. So under those conditions, your API may be existing as insoluble particles in your drug suspension. So we call it suspension, of course. So the particles are not solubilized, so it exists as kind of a coarse kind of molecules floating in water. Okay, so that's what suspension drug is. And another kind is if your drug molecule is extremely hydrophobic, then you cannot use water as your solvent. Instead, you're going to use what? Vegetable-based oil. Under that condition, we call that immersion drugs. So then how do we formulate those kind of extreme drug conditions? That's what we're going to talk about. Also, we'll talk about how do you formulate the drug that will be lyophilized, freeze-dried. Okay, so number one, dispersed system. Again, it means heterogeneous formulation, meaning everything is not completely solubilized. Okay, so things are not mixed well. So there are insoluble drug particles in aqueous, maybe water-based, or oil solvent. Okay, so the particles and solvents are not mixed well. That's what it means. Okay. So suspension is an example, immersion is another example. Some cases your drug molecule may be wrapped in lipid-based molecule called liposome, okay, or it may be coated in the micro or nanoparticles. Okay, so all these things combined together, we call them dispersed system. Okay, we'll talk about the formulation basics on those. So it can be aqueous or non-aqueous, polymeric, insoluble salt, or complexes. So all of those are included in the dispersed system. Okay. So vaccines may be a good example. Okay, so vaccines may have insoluble adjuvant in there. So we'll talk about that. So these particles that are not solubilized may come in different sizes. Some of them may be in microliter range. Okay, if they are too big, okay, large as in micrometer range, diameter sizes, then they cannot be injected through blood vessels intravenously. Intravenous injection is not possible. The reason is simple, right? If it's not, solubilized, you can clog up your blood vessel if you give it through your blood vessel. So you don't want that. So instead, you have to give it through your muscle, intramuscular injection or subcutaneous injection. Okay, makes sense because you don't want to block up your, main blood vessels. So microemergence nanoparticle systems have particles that are less than 1 micron size. If that's the case, there's a less chance of getting your blood vessels blocked by this. So you can give injection through intravenous method. Okay, so understand that. So number one, suspension drug. Suspension means, there are particles that are not solubilized, that are still maybe sitting at the bottom if it's not suspended, or it may be suspended when you vigorously mix up. Okay, those are suspensions. So a lot of them are mixed up with aqueous, means water-based solvent. Okay, and then how do you prepare these particles? So these particles may be prepared separate from your solvent, of course. They may be prepared in a crystallized form, okay, or lyophilized form, or spray drying form, or spray freeze drying form, or supercritical fluid process. So there are complex ways of doing it. So we're not going to talk about those processes, but understand the particles are prepared separate. So those are drug particles. Okay, and then the solvents are also prepared, of course. Maybe the solvent may be water-based, aqueous means water-based, or non-aqueous may be made up with something else than water. Okay, so they are prepared separate. If they are non-aqueous, meaning if they are made with something else than water, mostly they are made with oil. like sesame or peanut or vegetable oils, because strongly hydrophobic nature. So then this liquid, the solvent, should be sterilized separate from the drug particles. You could use filtration or steamed heat, like autoclaving method, to sterilize them. Okay, and after that, dry particles and solvents are aseptically combined during the formulation, of course. So when when they are combined, agitation is taking place, so they will be mixed up homogeneously. Okay. However, if they are left alone, so this is what's going to happen. So suspended form when you shake them up vigorously, but if you leave it alone, they may come back into this form, the settled down kind of particles, and the solvent separate from each other. So that happens. Suspension drug, that's the nature of the drug. Okay, they are separated. So then, a suspended drug, what kind of excipients are selected and added? Okay, so these are the examples we'll talk about. So number one is adjuvant. Adjuvant is a special term used in vaccine manufacturing. Okay, vaccines, you know what vaccines are, right? So COVID-19 vaccine, of course, or flu vaccine, or whatever other vaccines you're familiar with. Yes, vaccines should have the drug molecule that will be injected into human body, and then against that drug molecule, your immune system will activate and develop antibodies against it. Okay, but when you do that, a lot of vaccines require something called adjuvant. Adjuvants, sometimes made with aluminum. Okay, aluminum salt, or aluminum sulfate, or calcium phosphate. That are kind of particles, and normally the vaccine molecules, drug molecules, are kind of added to these particles. So they're combined with adjuvant. Vaccines, like antigenic molecules, are combined with these as adjuvant. Then the function of this adjuvant is, the main function of it is, when it's injected with your vaccine, the antigenic molecule. So adjuvant allows slow release of your antigenic molecule in your vaccine injection, so there's a prolonged, efficacy that's maintained in the patient's body. So does it make sense? So since your antigenic molecules are binding on the surface of adjuvant, when they're combined together, antigenic molecule with adjuvant, and from the site of injection, there's a slow release of these antigenic molecules into your immune system. So the vaccine efficacy will be prolonged. Okay, so that's the whole function of adjuvant. Okay, so a lot of vaccines have these adjuvants that are, again, are not water soluble, insoluble, so they are mixed up with the vaccine together. So they just have suspension form. Okay. Now another important component of the formulation is, of course, buffering agent. It's same as aqueous injectable drugs. You should maintain the pH of your drug molecules. So buffers are used for that. There are different kinds you can use, but sodium phosphate, sodium bicarbonate, sodium citrate, and sodium acetate commonly used buffers. Not much different than other drug kinds. And you also need to add some isotonicity modifier or adjuster. Okay, those are something that can give the isotonicity, the salt concentration. Okay, so they are added to minimize the pain. If there's a big difference between your bodily salt concentration and your drug formulation, it'll create a lot of pain. So to minimize that, you will add these isotonicity adjusters. Okay, so it'll minimize cell damage, like a cell lysis expansion burst would not happen. Okay, so examples are glycerin or sodium chloride or lone salt, right? And then, of course, preservatives, if it's a multi-dosage form formulation, of course. Okay, you need to add cresol, phenol, methylparaben, ethylparaben, or propylparaben, butylparaben, chlorobutanol, benzyl alcohol, phenylmercury nitrate, thimerosal, sulfuric acid, potassium sulfate, benzoic acid. These are all well-known preservatives. We talked about this in the previous lecture. And then stabilizers are also commonly used as well. So various kinds of stabilizers that will increase the stability of a drug molecule. Okay, they'll be added. Some of the examples are metal ions sometimes, or salts. Yeah, those are stabilizers. So the general requirements for suspension drugs overall. Okay, number one, suspension of a particle is accomplished with reasonable agitation. Okay, so when you have good formulation of a suspension drug, okay, with reasonable agitation, meaning kind of not really vigorous kind of shaking, okay, your drug should be suspended homogeneously. That's what the requirement is. Okay, so when you give an injection, you should be able to give the homogeneous concentration of the drug molecule to a patient's body. That's a requirement. And the rapid settling of dispersed particle does not happen. So when you agitate it, at least for a few minutes, it should stay as agitated, homogeneously agitated form. So whoever administers the injection will have enough time to give injection. So that's the requirement. Okay, and the particles can be homogeneously dispersed such that consistent dosage are obtained repeatedly. Makes sense, right? And the particles do not cake or pack at the bottom of the container over the shelf life period, making it difficult to disperse product. So what that means is when it settles down at the bottom, so this settled down part should not form any very strong structure, so they're not going to come into the solution very well. So that's what this where was it, the caking, so packing or forming a cake or pack effect. Okay, you should not see something like that. So that's the requirement, of course. And then suspension manufacturing process should be reproducible. Okay, so whenever you produce that, manufacture that, you should be able to reproduce the same identical molecule. Okay, so one batch to another, they should be the same quality in your drug manufacturing. Of course, that makes sense. Okay, and the suspension product must be easily drawn up and repeatedly expelled through 20 to 35 gauge needles. Okay. So I don't know if you're familiar with the injection needle gauge numbers, but I think the higher the numbers are, the needle diameter is smaller. Lower the numbers are, the diameter of the needle will be thicker. Okay, so 20 to 25 gauge. I don't remember exactly what diameter is. Yes, it's kind of small, thin needle. Okay, so through those your suspension particles should be able to go through without any problem. That's the requirement. Makes sense. Okay, so we talked about the suspension drug formulation requirement, and then we'll talk about emergent drugs. Emergent drug, again, these are what strongly hydrophobic drug molecules that are not water soluble. So instead, you're going to use vegetable oils as a solvent. And in those emergent drugs, you may have some lipid-based globules in your emergent drug. Those globules may have various sizes, maybe from 0.1 to 50 micron sizes. Although they're kind of big, they're not going to block your blood vessels, so it's okay to give these emergent drugs through intravenously, because these globules would not block your blood vessels, so it's okay. Okay, and there are large volume emergent drugs that have a volume larger than 100 milliliter, right? They are used for parenteral nutrition purpose. So parenteral nutrition means what, like amino acid mix or sugar mix. They are given to patient through injection. There are maybe patients who cannot eat eat and digest food, then you have to give these nutrients through intravenously or through the injection. That's what it means. Okay, so these emergent drugs are used for those purposes, and then so well-known emergent drugs are these kinds, like propofol, and then vitamins, dexamethasone, fluoroprofen, and prostaglandin. Those are well-known emergent drug formulations.